welcome to day 7 of Leetcode. Alright, so for this Leetcode, it's an easy problem. It's called maximum difference between adjacent elements in a circular array. It says, given a circular array nums, find the maximum absolute difference between adjacent elements, and in a circular array, the first and last elements are going to be adjacent. So let's first look at the first example. So we're given an array with elements 1, 2, and 4, and the max difference between adjacent elements is 3 because 1 and 4 are adjacent. You can visualize it as each previous number pointing an arrow to the next number, and then once you get to the end of the array, 4 is going to be pointing an arrow to 1, so it basically is circular, as in the name circular array. Okay, example 2, we're given negative numbers, so obviously the max difference between -5 and -10 is going to be 5, which is the output. The difference between -5 and -5 is going to be 0. I'm guessing this example is just showing us that there can be negative numbers in the array. And the constraints, the length of the array is between 2 and 100. And the values of the array is between -100 and 100. So the constraints are pretty lenient on us. It's probably why it's an easy problem. So I think this problem isn't that difficult to understand, so let's just try coding it up. Yeah. Alright. So actually, let's visualize it on the whiteboard first and then see our process and then translate that to code like I usually do. 1 second. My camera fell off a little here. Okay, that should be good enough. Alright, so I've already written the question and examples on the whiteboard. Let's just run through it, see how we can code it up. So for 1, 2, and 4, I'm assuming how we're going to do this is we're going to look at the first two elements. We're going to look at each adjacent element, and then we're going to calculate the difference. And then once we reach the end of the array, we're just going to do an extra step where we look at the first and last elements. I mean, that should be fairly easy. Same thing here. If we do calculate the difference here, -5 plus 10, because minus minus cancels out, plus 10, that would be 5. 1 minus 2, 4 minus 1. Yeah, I think that should work. If we just loop through the array once, have a variable which calculates the maximum difference, or which stores the maximum difference in a variable, we loop through the array once, we see what the max value is, and then we just return the result. I mean, that seems fairly simple. So max, we can initialize a variable max difference equals, I mean, the lowest max difference is going to be 0, right? Or no, it can be negative, the max difference. So I think this is how you do it in Python. Or maybe this is in parentheses. -infinity. Let's just see if that works on the console. I believe that's right. So we loop through the array, right? Loop through the array. So for I in range, length of nums. So we're starting at the first element, and then we're starting at the first element, and then calculating the difference between the first. So max difference equals. So it's either. If the max difference that we're currently looking at is larger than our stored value, then we need to change the stored value. So it's going to be max, either we're staying with max difference or the max difference is the current difference, and the current maybe we should have current difference equals nums I minus nums I plus 1. But then we do this because if we're looking at the element in front of us, then we don't need to go through the whole array. We can do the whole array minus 1. And then it's going to be between that and the current difference. And that. And then after that, we need to check the last and the first element. So we're going to do max difference equals max between the current max difference and nums length of nums, and I believe minus nums of 0, and then return max difference. Is that going to work? What do I do? Index out of range. Oh, wait, I think I can just do -1. Nums of -1, because that just means the last element minus the first element, right? Yeah. Yeah, right? Wrong answer. 2 minus 1, 1. 1 minus 0, 1. 0 minus 2. Oh, I think I know what the problem is. I think it needs to be absolute value. Right? No? Why doesn't this work? Oh. Oh, yeah, yeah. We got a lot more test cases. It's only because the circular part, and I didn't do it for this. We need to also do absolute value for here, and then this should be the right answer. Cool. Okay, so that was fairly easy. Let's see if we can optimize it. What I actually want to see here is if we can just get, we're optimizing it for runtime, so it's easier to read if we have that current difference variable up there, but I think it's actually faster if we just do it in one go like this. And I also feel like this in check between the last and the first element is causing some, it can be optimized, I feel like. It's not intuitive how we can optimize it off the top of my head. Let's see if this little changes faster. Oh, okay. Yeah, that variable swap was just got us there. Do you really need this though? I feel like it's kind of clumpy if you have to do it. I mean, we're in the 100th percentile in terms of that. I don't know if it's just. Or perhaps we can actually start the max difference between. We can start the max difference with nums 0 minus nums of 1, but we would obviously have to do the absolute value of that. And then we can start at 1 and do that. I don't know if that would be faster. I mean, yeah, that's our solution. It works. Very easy. Took us like 10 minutes max. Let's see if there's an optimized way how to do it. So yeah, so they start out by doing what I did up here, right? I'm 0, n minus 1. Oh, that's kind of smart actually. So instead of having to do this check at the end, they actually initialize max difference up here. That's actually very smart, I feel like. So we can actually start out max difference here so we don't have to do the check at the end. It makes it a lot cleaner actually. And then that should work, right? Wait. Access max difference where it is not associated with a value. Oh. No, we don't have to do the max. So we can just do this. Right? And that should work. Oh no, we're not starting out. Sorry. Okay. Yeah, this should work now. Cool. Why is that so slow though? Absolute value result for I in range n minus 1. I mean, is that not the that's the exact code I have. You can use modulos to achieve a single loop without having to do something to make your code a little more concise. For I... Oh, modulo. That makes sense. But it's slower. Negative indices? Aha. That's actually smart because negative indices kind of already makes the array circular. See some other implementations. I mean, yeah, this is the exact. Okay, so C++ also has the max and absolute functions. Java doesn't. They have math.max and math.absolute. It's cool seeing the difference between all these languages. yeah, I mean, very easy solution today. Hopefully tomorrow is not a hard problem like it was yesterday, where it's just like impossible to figure out unless you have deep understanding of these concepts. Um, I'd be fine with a medium problem though. But that's today's solution. On with the grind. Peace.